Welcome to Discover ASAP, the video interview series where we highlight the top findings and tools connected to the ASAP network. Today, I'm talking with Dorotea Fracchiola, the project manager for Team Hurley. For today's episode, we're going to be discussing communication as a key component of open science and how art can be used as an effective means to communicate science. Thanks so much for joining me today, Doro. Can you start by introducing yourself?
Yeah, hi Dana. Thanks for having me at this ASAP Discover ASAP series. Actually, I'll just mention this as a science communicator. It's great to get a video out about what science communication is and how it matters for the actual entire world. And so thanks for having me on board for this. So as you said, I'm Dorotea, and I'm currently project manager of one of the 35 ASAP funded teams, namely Team Hurley. We also like to call ourselves Mito 911, and that has to do with what we work on. I can talk a bit more about that if you like. Sure. And so, we are interested in mitophagy, which is one of the cellular processes that happens when waste accumulates inside cells. And so it's a little specification of autophagy, which is a bit of a bigger realm of processes. And in particular, mitophagy consists in the degradation of mitochondria, which are organelles that we find inside cells. And so we called ourselves Mito 911 because, as you know, 911 is the number you dial in US when there's an emergency. And that's when mitophagy kicks in cells when a mitochondrion actually has an emergency. And so we think that mitophagy has to do with the onset and progression of Parkinson's disease. And that's why our multidisciplinary team has decided to focus on this and find out what it has to do with Parkinson's disease. But beyond that, I said I'm project manager for Team Hurley Mito 911, but I'm a scientist by education, so that came much before than this. And at some point, actually, in 2020, when the COVID-19 pandemic hit the planet, then I decided to become a science illustrator because, we were away from the wet lab work and we had a lot of time at home. We couldn't work. And so I thought I could couple my scientific knowledge with one of the things I like to do in my spare time, which is painting and drawing and doing art. So nowadays I consider myself a science illustrator. Then this developed into being a science communicator because for the reason why I'm talking to you today. That's why I am.
Great. So I would love to hear you talk about, why you decided to get into scientific illustrating and what your goals are as a scientist who is using art as a part of what you do.
Yeah, thanks for that question. It's actually, that makes me go back to the very beginning of how all of this started. It was a very personal journey. When I was a kid, I was always very interested in everything, but specifically in understanding how things happened around me, like in the world, in nature, mainly. And so that's when I went to school. I started to study, biology, and then later on chemistry and physics. And I understood that these were the topics that would have allowed me to understand more about the world. And so I also found out that I really like to understand the mechanistic aspect of nature. So I went on with my studies after studying biotechnology at the university. Then I did my PhD, and that's the time when I became a scientist interested in the mechanisms of autophagy, this process I introduced before. And so what I learned from being a scientist in this field, and for the techniques I was applying, the world is very complex. Nature is very complex, but if you have the right tools, you can actually simplify what you are learning, what you are studying. And so you can find even out what are the essential, the sufficient, the necessary elements that can make a process happen. So this is the core philosophy or the core thinking I have when I do science, and then I use this and brought this into scientific illustration. So I was saying that's when scientific illustration comes in, and so it borrows the concept of going from complexity to simplicity, and so what I'm trying to do with my illustrations is to represent in one image, in one picture, complex processes. And so that's my goal. That's the goal of getting people interested in science, touching the spot of curiosity, which is in everyone. And so I hope this effort of mine will help people get more interested in scientific knowledge and everything that happens in a closed laboratory.
Sure. I think that's so important to get people who are not in the lab interested in helping in what we're doing, and also in helping them understand the very complicated, often nuanced things that come out of a lab. So you've just talked a lot about how you see art as and science communication as taking these very complex ideas and breaking them down into more digestible sort of pieces. And I'd love for you to talk more about what your process of that is like. How do you take your science and transform it into art?
Yeah, that's a really good question. It's not a trivial task. I found out. I thought it would be simpler. And so when I used to illustrate about my own science, probably half of the job was already done, because it was science I was making myself. And so I had a lot of knowledge in that topic. And the next step was actually to come up with an interesting idea to present that science. But what usually happens when then I started to have my own activity as a scientific illustrator was that I need to create an image for clients, for other people, other scientists, other colleagues. And I didn't really know all of the science behind it. So always the very first step for me is to actually sit down and read and study and create a network of informations in my head just to basically understand the topic. So read a lot, study a lot, and talk with the people that do the science, ask questions, and communicate already at that stage. As I was saying, the most time-consuming part is, or actually the bottleneck of the whole process is coming up with an idea that can represent the topic. And so there you have to make some choices, of course, what you exactly want to highlight of that piece of knowledge. And so you need to focus on one aspect. And once you get an idea of how to illustrate and represent the topic, then you are almost done, because then it's just fun, to illustrate, to paint, or to draw that idea. I will add that when I try to come up with an idea, because science communication is trying to present complex and technical and specific specialized concepts to a lay audience, a general public, you need to go a bit away from these technicalities, from this specialized language. And so you need to fish more into the pond of similarities or analogies or metaphors. And therefore, it helps a lot to have your feet on ground and think, okay, what do usually people relate with? What type of metaphor or daily object can I use to express this one concept? And this is the part I really like, because it's a lot of mental thinking, mental game almost, finding out the best metaphor for this one aspect you want to talk about.
Yeah, I think that's really great, and I think we're talking about this in the context of creating art about science, but I think it's something that all scientists should probably be engaging in and thinking about, even when we're writing papers or giving a talk or any sort of process of communicating our science. And so, to that end, I wonder if you can expand a little bit on how you see your work as a scientific illustrator in the context of open science also.
Yeah. I think, like, by definition, when you do science communication, and particularly when you use illustrations or drawings, paintings, so visual arts, you are already in the area of open science, because you are making. So what I and most of the people do in a lab is trying to understand the microscopic scale, what happens at the microscopic scale, which is not directly accessible by the view, by the sight of anyone out there. So you will be trying to represent something that you don't really see into an image. That's very challenging. So if we didn't have microscopes to see how a molecule could look like in isolation or in its native environment, then we already there wouldn't be able to see much. Plus, when you want to represent a mechanism, you need to relate to something to represent it. So already the fact that you put such an abstract concept into an image, you make it open for somebody. So you open the way for people to understand it. It's also common knowledge that around 80% of the inputs we receive from the world out there actually comes through the site when that's enabled in people. This also touches a very sweet spot for me. That's there are so many other people that cannot see, actually, so they have the sight disabled. And I think science communication can do a lot there, using all the other senses that a human being is capable of. So like the touch, for example, or the smell. And I have a couple of projects that go into this direction. So creating 3D objects that still represent the one topic I'm interested in, like autophagy, and that blind people can touch, and by then trying to imagine how an organelle, a mitochondria, and an autophagosome are made without seeing them, actually. So for me, science communication is open science at the very core, because it makes knowledge available through the view. If you add on top that one tries to be a bit artistic, then you could even reach out to many more people that, as everyone has an innate sense of beauty. And so if you find the right people that like your style, and then you can reach out to many. On top, there are so many science illustrators that probably all tastes are probably covered by now. So probably the whole world can access science through this channel.
I love that. So I want to talk a little bit more about some of the art that you've created that's specific to Parkinson's disease. So you have a lot on your website about autophagy and the things that you study, but you also have created a set of paintings for ASAP representing, the Parkinson's disease and what we know about it. And so I was hoping you could talk a little bit about these paintings and what you hoped to communicate to people outside of the research community with these paintings.
Yeah, sure. Thanks for the question. I really like to talk about these paintings, because these are really probably the best example of how you can go from a very specialized field and beyond that also a very specialized audience, and open that science to the people outside that little circle. And so, yeah, if we have a chance to look at these paintings, so one of these series is the series representing Parkinson's disease, and the science that is being made by the Collaborative Research Network funded by ASAP. And so there is a common theme in this series of paintings, which are two paintings. I've represented the planet Earth in the middle. And then there is the alternance of, in one case, in the first painting, rising of PD of day to night, and in the second one, which is towards ending PD, we go from dawn to sunset. So there is the topic of time passing. And so what I wanted to express here, because they both focus on Parkinson's disease as a neurodegenerative disorder, is that time is a big factor that one has to to deal with when Parkinson's disease arises. So this is a progressive disorder. It goes on with time. And so in the first painting, we go from day to night, and this expresses the passing of this time. But it's not all black and white. It's not only day and night. It can also be dawn and sunset, which are these two intermediate stages of the day. And that's what I represented in the second painting, which in general also, in this one, beyond representing dawn and sunset, there is a lot of elements that hint at the uncertainty of what's not black and white, but it's actually gray. There are all of these clouds which are in part under light, in part in the shadow. And this is to mention that there is so much research that still needs to be done, but a lot has actually been done thanks to the work within the ASAP CRN and all of the other initiatives like the GP2, PPMI in the EPD and AMPPD. All of these initiatives have shed a lot of light already on how Parkinson's disease goes. There are other elements that I wanted to highlight. And so the idea of using the planet Earth is actually to illustrate the global nature of the ASAP CRN. We have scientists from really all over the world. Probably no continent is not represented in these paintings and in the reality of the CRN. And this is one aspect, and the other one. So I drew some of these trees, what one could think are trees, but actually they are there to represent the human brain all around this planet Earth. And so in the first painting, you can actually see how they go from being very lush to be when night comes to be darker and actually neurodegenerated. So they are there to represent the progression in the human brain and how this brain changes over time. For this first painting, one other aspect, one other element I would like to draw your attention to are the roots that you can see deeper in the soil. So if you follow clockwise, the direction clockwise, you'll see how these very arborized roots become less arborized when you go towards the night. So they are there to represent the actual anatomical structure of dopaminergic neurons, which are the mainly affected neuronal cell types in the brain of PD patients. And what actually happens in these neurons is that they lose arborization. So they lose the physical contact with other dopaminergic neurons. Thus, they don't work properly because, as we know, nervous signals or neuronal signals have to go through a network to give an effect, a functional effect. Well, and in the second one, towards ending of PD, the one aspect and element I want to highlight is standing on the left of the painting. There is this person harvesting some fruits from a tree and collecting them into the basket. And this is there to represent one of the major advances that the network has reached, which is to set up an actual assay called the seed amplification assay, where now scientists can actually detect a marker for PD pathogenesis in the cerebrospinal fluid of prospective patients or any other person, and then predict whether that person is likely to have Parkinson's disease in a few years. So it would be the first laboratory assay that we know of that can be used to diagnose Parkinson with quite an advanced time. So
that's great. I know these paintings are quite rich with detail. I think we could probably talk for a long time about all of the little hidden things in these paintings. And if anyone who is watching this wants to really dive in and learn more about these, Doro has written a blog post that we will link in the description of this video as well, that you can check out to learn more about these paintings and the other paintings that she's done for ASAP. So before we finish, Doro, I just want to ask what it is that you plan to do and hope to do with combining your love of art and science in the future.
Yeah, thanks also for this question. What I have really at heart is bringing this into the school world, so to children, because I see myself a lot when I was a child, being so curious and interested in getting to know things of the world. And so I believe there are so many kids out there that have the same drive. And I want them to have an opportunity to actually express it and experience how fun and cool science is. Because we need scientists out there, especially when these people become adults, they can give a really big contribution to the society, both when it comes to health, when it comes to the environment. So people need to be aware that they can participate in the society in this very professional and specialized way. So apart from that, I have like my own dream in the pocket, which is like to one day maybe illustrate a children's book that again talks about nature and how the world works. And so it would be great to get in touch with some writers that are happy to write a story, and that I could story tell by drawing images.
That's great. I love this mission of yours of making sure everybody from the youngest to the oldest has access to science and information about Parkinson's specifically. So thank you so much for taking the time to chat with me about that today.
Thank you, Dana. Thanks for having me. It was a pleasure.